Um, I can't remember if it was you that told me about Axum or someone else. I think it might have been someone else. Yeah, nice to see you again. But I was looking for someone that was doing like functional programming in Rust, and I didn't find anything that looked particularly appealing. But the person that wrote this is very good at functional programming, from what I can tell, and he is a big fan of Rust, just like anyone that's ever tried Rust. And he wrote this pretty lengthy blog. So I'm gonna try to learn some web and some Rust and all that at the same time. Not sure I told you about it, but I sure am hyped about Axum. Yeah. I mean, I feel like I would be more excited about it if I knew what it was or like was super good at using web stuff. But I can definitely see the appeal because it seems like it's just super modular. Does that sound right? Let's see what he says. Played around with various web server libraries and frameworks in Rust and found various strengths and weaknesses with them. Most recently, I put together an FP-complete solution called ZHut, which I'll blog about at another time, that needed to combine a web front end and a gRPC server. See, I don't know what any of these words mean. That's the problem. Like, what is this? I used Tonic in a minimal library I put together called root type. Okay, so he built his own. It worked, but I was left. Oh, but we're not going to do that. Okay. Working directly with Hyper, even with the minimal root type layer, felt too ad hoc. When I recently saw the release of Axum, it seemed to be speaking to many of the needs I had, especially calling out Tonic support. I had decided to make an experiment of replacing the direct Hyper plus root type usage I used with Axum. Overall, the approach works. Like the root type work I'd already done, involves some hairy business around Hyper and Tower. It's like Warp, but better. Yeah, I haven't tried Warp. You have no clue what gRPC is? Well, we're gonna learn together. Let's see if he explains it before I look it up. So this is Axum. This is not the website for Axum, no, I'm sure. It's a web application framework that focuses on ergonomics and modularity. Yeah, it's modularity. My deep insight seems to have just been plagiarized. I know Axum is a HTTP server based on Hyper, and it's official from Tokyo. I checked out the gRPC website just a second ago, but I still have no clue. Yeah, it was funny because I actually was already in the Tokyo Discord, and then I joined the Axum Discord, and it's the same Discord. They just have different channels for the. I just didn't even notice that channel was there. Let's see. I've been meaning to write a blog post for some time, so I decided to take this opportunity to step through these 4 libraries. Okay. The specific goal of creating hybrid web gRPC apps. It turned out that there was more information here than I anticipated, so we split it up into 4. Okay, so let's see. What is this? Oh, it has its own thing. High performance, open source, universal RPC. So remote procedure calls. Modern open source high performance remote procedure calls framework that can run in any environment, can efficiently connect services in and across data centers with pluggable support for load balancing, tracing, health checking, and authentication. It is also applicable in the last mile of distributed computing to connect devices, mobile applications, and browsers to backend services. Yeah, see, I don't deal with the web much at all, so I've never had to do any of these things. Tower also looks interesting, but according to the description on crates, it only supports Warp and not Axiom. Or not Axum, so maybe that's outdated info. Yeah, that sounds outdated, because I think Axum is built on top of Tower, or at least uses Tower. But we'll see. So let's see, what is Tower? Let's find out. So, first stop on our journey is the Tower crate. Zip with the docs, which state this succinctly. Power provides a simple core abstraction, the service trait, which represents an asynchronous function taking a request and returning either a response or an error. This abstraction can be used to model both clients and servers. I remember you being pretty good at just going through docs, which I'm not very good at. So I've got to practice that. This doesn't look like the documentation though. Is it this? Where's the, yeah, okay. This is what I'm familiar with, the little gear. Modular reusable components for building robust network clients and servers. Yeah, so we just verbatim this. gRPC is somehow managing to do the same thing that Kubernetes does with its introduction to throw around a bunch of technical words, the meaning of which you could possibly know without knowing what Kubernetes is. Okay. Oh, is there a limit to... I wonder if I can change that. Maybe. I'll note it. I'll take a note for next stream. Maybe you have to be like whatever the YouTube equivalent of partner is. Move 200 car limit to chat. On chat. All right. I'll see if I can take care of that before next week. Yeah, probably not, but I'll give it a shot. Anyways. Okay. Sounds fairly straightforward. Oh yeah, this guy does a lot of Haskell. That's why I knew he was good at functional. It's like never trust a skinny chef. Never trust a functional guru that doesn't know Haskell. Probably say request returns IO response. Leveraging the fact that IO handles both error handling and asynchronous IO. But the service trait is necessarily more complex than that. Simplified signature. I just remembered use the proper system select. Linux i3 and Vim. Yeah. I somehow figured that out on my own. But I like it a lot. It makes it really frustrating whenever I go back to my day job and I'm like using my mouse. But there's still a lot of work I need to do on my Vim config though. I kind of want to go through this manually so I get it into my hands, but I don't see him having this posted anywhere. So I guess we'll just read through it until he has a working version posted. I'm still pretty new, so I need to like see something that someone else wrote that's working before I can, otherwise I'll drive myself crazy. Is that i3 blocks? Now this is Regolith. I had no idea what i3 was, and this was just the first thing that I found that worked. It has a couple things that don't work very well, but it required like 0 customization from me, so I just never had a reason to try something else. Yeah. So what do we have here? Let me make this smaller just for this. I wish I could get rid of this gigantic header. Let's see. It is i3. It's built on top of i3, but it is i3. I've never used like i3 directly though. Doesn't require any customization either, but you have a simple config file if you want to change stuff. Okay. Yeah, I just haven't tried it. I saw this and it said that it was made to work with Ubuntu. So that's why I picked it. Did I? Well, it was long enough ago for both of us to forget, so it doesn't count. So what are we doing here? Club trait service. takes a request, type response, type error, type future. So it has a response, an error, and a future. This is what it says in the generated docs. Shouldn't the future be part of the response though? Or does it need a future? It needs a future to run itself, I guess. Let's see. But this more informative piece is the actual source code. Okay, so the future is actually an output with a result of self-response, self-error. Okay. And then it has pull ready, a pull ready method with a reference to mutable self, and then a reference to mutable context, an anonymous lifetime. And it returns a result, error. So this is just going to say that it is available. Okay, and then call request returns our future. So this is going to be our actual output. So this is checking if it's ready, and then this is actually executing our logic. Right? I am on Ubuntu. Is that a mistake? I come from data science, so Ubuntu was the only Linux that I thought I would be able to actually put on a machine. I chose the worst one. Oh dear. Is it the worst one? Should I just be, I saw there was a guy that came in the chat a while ago that was using, he wasn't even using Arc, he was using something else that was like more to the metal than Arc somehow. And I don't remember what it was. Why is it the worst? I believe you. I've heard people say that Debian is just bad in general. I think it was Torvald that said that. Service is a trait, parameterized on the types of requests it can handle. Right. Okay, so we're like building a trait based on what it can handle. That makes sense. There's nothing specific about HTTP and Tower, so requests may be lots of different things. And even with Hyper, an HTTP library leveraging Tower, ooh, maybe Axum is built on Hyper, which is built on Tower. That would make sense. You'll see that there are at least 2 different types of requests we care about. It's proprietary? Is it proprietary? I didn't know that. Includes a ton of bloat, comes with one of the worst desktop environments. The stupid snap package. I do not like the snap package. I figured that out. Selection of about 5 packages. Yeah, I could see all that being true. Like, we installed it on a computer at work, and there's a mode where it like includes a bunch of junk that's not even like low-level junk. It's just like an Amazon app and stuff like that. It's like, why would you want that? The super outdated kernel. Debian only updates to a kernel once it's officially unsupported. Ooh, that sounds bad. Is there a company behind it? What's the company? I didn't know this. Anyway, 2 of the associated types here are straightforward, response and error. Combining the parameterized request with response and error, we basically have all the information we care about for a service. Okay, but that's not an async service. But it's not all the information Rust cares about. To provide, yeah, okay. For asynchronous calls, we need to provide a future. The compiler needs to know the type of the future we'll be returning. This isn't really useful information to us or to use as a programmer, but there's plenty of pain points already around async coding traits. Async trait. Canonical. Literally the only distro worse than Ubuntu is Windows FX. I don't think I think I have used Windows FX and it was not good. So you're probably right. What is it called? Canonical? Canonical. I haven't got it typing. What is this? Oh, you're totally right. What is this? Get out of... See, you know they're messed up because they're trying to just manually give me cookies. Oh man. How did I not know this? UK-based, private-held computer software company founded and funded by South African entrepreneur. Only 443 people. I thought it was like fully open source. How do they make money? Try that in a VM. Hard to believe it's not a joke. You tried Windows FX or you tried Ubuntu? We recently updated at work where you got pushed to the new Windows, and it's actually pretty nice, surprisingly. It obviously doesn't do all the low level stuff that you would want. At least from my view, it doesn't. But Windows FX tried. They make money by selling support to people who are stupid enough to install Ubuntu on their servers. Yeah, I wouldn't install Ubuntu on a server. So they're like Red Hat for people that make mistakes. Finally, what about those last two methods? They are there to allow the surface itself to be asynchronous. It took me quite a while to fully wrap my head around this. We have two different components of async behavior going on here. The service may not be immediately ready to handle a new incoming request. For example, coming from the docs on poll ready, the server may currently be at capacity. You need to check poll ready to find out whether the service is ready to accept a new request. Then when it's ready, you use call to initiate handling of a new request. Right. I think that's basically what I was figuring out earlier. The handling of the request itself is also async, returning a future, which can be poll awaited, right? Yeah, so this returns a future, and then this takes a future? No, that doesn't make sense. I guess you implement this with async. That's probably wrong. Yeah, yeah. Oof. Well, how hard is it for me to switch to something proper off of Ubuntu? And what should I switch to? Some of this complexity can be hidden away. For example, instead of giving concrete type for future, you can use a trait object, aka type erasure. Stealing again from the docs, the following is a perfectly valid associated type for future. Inbox dynamic future output result self-response self-error. So that means that this is using this error and this response, I guess, for this future. However, this incurs some overhead for dynamic dispatch. If you know some basics, you got Arc installed in 2 hours max. Well, I think one of the reasons I was using Ubuntu is for the GPU stuff, but I'm sure you'd be able to use that on Arc as well. I'm actually not sure that... Oh, how's it pronounced? Arch? I've heard people in videos pronounce it Arc. But yeah, it's not spelled that way. I should make a different distro called Arc just to mess with people. Finally, these two layers of async behavior are often unnecessary. Many times our server is always ready to handle a new incoming request. In the wild, you'll often see code that hard codes the idea that a service is always ready. It's a quote from the docs for the final time in this section. So pull ready, they just said it's always ready. Pull ready, okay. I've done some totally legitimate Hashcat cybersecurity research with CUDA. Okay. Yeah, I guess I just didn't know what I was doing at the time. Because now that I think about it, I don't see any reason why you wouldn't be able to do that, like you're saying. I didn't know you were into cybersecurity though. That's cool. Cybersecurity is one of those worlds that's like a whole universe onto itself that I haven't jumped into. This isn't saying that request handling is synchronous in our service. It's saying that request acceptance always succeeds immediately. Going along with the two layers of async handling, there are similarly two layers of error handling. Both accepting the new request may fail, and processing the new request may fail. Yeah, so the fact that you're ready might fail, and then what you're doing once you're ready might fail. But as you can see in the code above, it's possible to hard code something which always succeeds with OK, which is fairly common for pull ready. Sorry, it's the dog. Ah! There's a car outside. When processing the request itself can also cannot fail, using infallible and eventually the never type. Work. Is that like super loud? I can shut the door. She doesn't like it. Okay. Let's see if I can. No, come here. We got her a little Ferris. So let's see if she comes up. Come here. There you go. All right. Hopefully she doesn't bork into the mic. I was cracking a spreadsheet, but I do actually care about cybersec. Okay. Well, same page then. Go. Her mom's not here right now, so I'm on dog watching duty. Okay, fake web server. All right, we've got some code. Sweet. It says a gist. Let's see. Let's see if I can do this over here. That is incredibly, it is incredibly loud. Okay, well. Hopefully she stopped. Where were we? Let's see if I can. Do I have a thing here? Yeah. So let's see what we should do. Let me put this off to the side. Oh, nope. We're gonna get good at this, I promise. It's a Cliff can code? A long time. Apparently. Once I stop needing people to hold my hand by looking at what they've already done. So let's see, how's this set up? Main, it's got a main. I guess I've just done this entirely wrong. What I want to do is this, right? Cargo new. I guess I don't. I guess that was fine. I want to do it here because there's multiple of these. Yeah, there we go. Let's do this. All right. And then we want to go to the source. I guess we can just open this. Whoops, that's not right. Oh crap, I closed the whole terminal. See, this is why my name isn't Cliff Canton Code. Where was I? I want this. There you go. Yeah. Yes. Oh. What was the thing again? I haven't used any of them in a while. I've not found Twitter. What? I think it was. There we go. Right. Now we're talking. That was painful. So let's see. Let's see what we've got. I move this. Here. My goodness. There we go. Then you press the combo to search in your clipboard. You didn't have your password in your clipboard. Yeah. That would have been bad. I don't know what I would have done. Note to self, don't put your password in your clipboard. I make all my passwords different, and then I always type them out so that I make sure I remember them. So what were we doing? I forget. So let's see. Okay. So the main for this is going to be Tokyo main. Just to start from the bottom here. Let's go to async. No type passwords you can type out on a normal keyboard. Yeah. What? How do you do it? Do you have like a bioscanner? And then this is going to be bad security practices. Yeah. Oh, you have a password database. My brother is really into crypto, and he was trying to give me passwords, and I told him that he should get a password database, even though I don't use a password database. Extended async 32 character high entropy settings. I know some of those words. No, that makes sense. It was funny at work, my manager is actually really into cybersecurity, so he like made a randomized password and then forgot it, so we couldn't get into the thing we were doing. So extended async 32 character high entropy strings. What did I say the first time? Something dumb? Whoops. So we want a fake server. It's going to run an app that he's going to call demo app. Default. We're going to wait it, obviously. Okay. Still set it wrong? I said ASCII. You're gaslighting me now. Really? I'm gonna have to watch the playback on that one. I don't believe in the Lord. I swear you said async. All right, I'll believe you for now, but I am gonna watch this again because I gotta do edits and stuff. So we'll see. At least I'll see. Okay. So we're making our HTTP stuff. So this will be educational because I don't know much about this. We're using standard collections. We're using HashMap. Choose separate files instead of those inline modules. I think this is just like a super quick example is why. So it like fits all on the same screen. But that's the same thing, right? It's just worse practice if you're gonna go beyond modules. I don't know. Yeah. Okay, well that's good to know. See, this is why I need people that actually write code, because I didn't even know the difference. I think he does it differently later, so we'll see. But I do think this will run once we're done. So we're building a public struct for request. Makes sense. Query, just using a string. HashMap. This is wrong. Body. U3. Get yourself an auto-close plugin for NVim. Oh yeah, that's a good point. Let me add that to the list. Yeah, there's a bunch of plugins I need for my NVim. It's the little things, you know. Actually, like that open. Where are we? That's a good catch, though. Let's see. So our request has the path and the query, the headers, and the body. Oh yeah. It's also nice because I'm missing a thing here, right? Is it not gonna auto space it for me? Anyways, we're going to derive. It's wrong. And this is probably like watching someone run through mud for you. But I'm trying. It's stuck. Okay. So we need a status for the header, all right, status for the response, a header and a body. Status. To headers. Body. It's like the request. Right. Yeah. I think we should be focusing on fake server first. Oh yeah, we need to add this stuff to our TOML. First I thought you were slow. You're already writing your second struct. Oh yeah, because the spacing was off. Let's go add this to our TOML though. Was it Tower Tokyo anyhow? And he's using 0.4 for tower. We can just match that, I guess. I am slow though. Don't be fooled. I always forget the syntax for this. It's bracketed, always. Bracketed in features. And version. It's like this, right? It's like this. I think that's right. Features equals full. Yeah. The version number is text. And then we have it struck you. I didn't even catch it. You know what's worse than a pun? A pun you didn't even catch. Can I put the 1.0 here, or it might be the same thing? I think that's right though. Let's see. Okay. So let's focus on the fake server now. Let's see if I can understand this. God. Yeah. Now that you mention it, the non-self-closing curls is quite annoying. Oh, I just realized I missed this. That would have been bad. Okay. Still using hash map. And then we need a tower. Oh man, the other day I was on Twitter and I saw someone explain what the curl extraction is for the command line. Blew my mind. That was crazy. Pretty sure it works for imports as well in Rust, which is nice. Okay, so we're making a run function. that takes an app. Okay. So if you've done web stuff, this is probably super boilerplate for you, but I've got to get used to how this all works. So app service, right? So that should be the tower service. In create HTTP request response. Let's create HTTP response. Okay. Okay, this is kind of nice because I think this is going to be like a pretty repetitive API. So the error for the app is going to be standard format bug. Okay. Keep doing that. And in the future, it's going to be send plus static. So does the static there is just going to last until the feature runs, not after the feature runs, I'm pretty sure. Which makes sense. Okay, I think that is all right. We can do another one of these things painfully. And then make a loop. Oof. Right. And we're going to use Tokyo time sleep duration. Sex 1. So we're going to wait 1 second. And then we're going to assign our request. I'm sure he's going to explain this in the article, but let me see it. You know? Okay. Man, this curl thing is super annoying. You're totally right. Okay, path. And once you realize there's a better world out there, you can't go back. Right, fake. It's like with fish. I don't know how I was not using fish. Path age equals 1. Path 2 owned. So 2 owned. What does this do? Does this basically just make it a string slice? I think. Let's find out. Good old Stack Overflow. Yeah, okay. I think that's what it says. Anyways, So that's the path for our request HTTP, which makes sense. And then headers are going to be hash map, new, body, tvec. Okay. So that's our request from this fake page one. Which means that this needs a semicolon. No. This does need a semicolon. Okay. I was getting this mixed up. Okay. So we're going to build our app. It's a match for app ready. Wait. Right. Yeah, okay. So if it matches on error, print line. So it's not able to accept. Does this make sense? Yeah. ePrint. This returns a service request error. Okay. And then I've actually done this wrong. This should be closed here. And then there should be an OK section. Which just returns the app. And now that matches up. Okay, cool. I think that all matches up. Nice. So now, we have to put the feature. There's a bunch of stuff. Okay. This app. Let's spawn async move. Match feature dot awaits. Man. You couldn't have told me this at the end of the stream when I just keep making the curls now and it's super painful. That's okay. That I know I can fix. I don't know if I can fix the 200 character thing. It's probably made to prevent spam, not made for live code streams. Where was I? We made a Tokyo spawn, and then we're doing an async move. Interesting that there's no closure there. Oh, it's a move for the spawn. Okay, I see. So res is... No worries. Messing around with your env config with something in the background is... It's a fun way to spend some time. I'm mostly just trying to figure out what I'm doing anyways. Or what this guy's doing, at least. So we spawn a Tokyo, or we make a Tokyo spawn, and then we're moving the match of this future into it. So if the future, after we await the future, if it's an okay, then we print success. If it's not, we print error. That's another reason I like YouTube, because it saves the videos. So that one day people are going to come in here and be like, why is your name can't code instead of can code? And then I'll be like, go watch the other videos. I have proof. Did I do this right? This is here. This is not being closed though. I think I missed this. I think it lined it up for me too. So that's good. Okay, yeah, I missed it. Cool. Okay, so the last thing we need is the app. What is this doing? We're doing the time for the sleep. And we're building the request to this page here. So this is returning the app. This is returning the future. And then this is running it. Okay, so we have our request, our app, and our future. And our future can return error, and our app can return error, just like the guy was saying. Okay. And then this is here just to overcome Rust's biggest downfall, which is that it's too fast. You won't be able to see what's going on. Okay, so let's build our app. Where do we go? Here. Do another mod as per best practice. No. Yes. Got it. Okay. Use standard. Okay, so we're gonna use a lot of standard library stuff here. So we're using future. Any pin. Oh god, we're gonna deal with pins. Think. I didn't even know that was a thing. I thought that was just default behavior. Oh, for arc, I see. I see. Atomic size and arc. ARC. That one is actually pronounced arc, I'm pretty sure. Did you know NeoVim supports Lua configs in new versions? And the best part of that is that thanks to the Lua crate, you can super easily create Lua modules in Rust. Ooh, that sounds fun. Yeah, I've been meaning to change everything to Lua, but I want to do everything in Rust. So that's super cool. Maybe we can, because I do need to figure out something to do the week after next. So maybe I'll find something to queue that up. Let me look that up. In Lua. Because today I'm just doing part 1 and 2 of this, since it is pretty long. you can have a one-line Lua config that imports the Rust module and do everything else in Rust. See, that's the sweet spot. Bare minimum of everything else, maximum Rust. You don't want to get rid of everything else completely, because that's so much work that's already been done. Speaking of which, minimal C. You give it 2 stars? Well, I can give it a star. There. Now you've given it 2 stars, because you told me about it. It's good for embedded scripting and Rusty Lua modules. Well, that's interesting because I saw somewhere when I was looking at stuff to try to improve the stream that I saw someone made a Lua script to like control something with the visuals on their stream. I obviously have no idea what I'm talking about, but that would be super cool. Let's see. In Lua is bindings to Lua programming language for Rust with a goal to provide it safe as far as possible. High level, easy to use, practical, and flexible API. Started as our Lua fork. In Lua supports these versions, LuaJIT. Yeah, I've obviously never used Lua that much, so, but I've heard it used everywhere, so. Including module node GitHub Actions. Yeah, this sounds super cool. Only has 320 stars. Man, open source never ceases to amaze me. The bindings are just amazing. You're not getting bindings this good with any other embedded scripting languages. Even supports async. Wow. Yeah, I'll have to look at that. Let me take that as a note, actually. Cool. All right. Yeah, I'll definitely look at this. See if I can find a stream behind it. You always have the best pro tips, Lord. Mod app. Yes, of course. Oh. Oh, okay. Okay. BRB. All right, no worries. My girlfriend just flashed me food in a takeout box, and it smells delicious. Motivation. Thank you. Okay, so we're making a struct for the demo app. Counter arc. Tonic size. I didn't put the comma there. I love the fact that you can put a comma there. I didn't do it. Okay, so our demo app is just a counter with an atomic usize. An arc. Bool defaults. Demo app. Functional defaults. Self. Counter. And I feel like I'm just living on the edge, not closing my curls immediately. Make you size. suppose. Oops. One more. I think. Yeah. The default for the demo app is self returns itself with a new at 0. So counter starts at 0 basically, I think is how that works. Okay. We're back. Welcome back. We're almost done with this part, I think. We need to implement the actual service for the demo app, though, now that we have the counter built. Man, I'm not very good at coding, but the more I learn about Rust, the more I like it. It's just so nice. Can't wait to be good at it. Okay. So we're implementing this service, which is the main point of Tower, apparently. So we need the response type, the error type, and the future type. And then, yeah, so it's response, error, future for the types, and then it's pull ready and then call. And I think that's pretty much the main setup for all Tower services. And I think the idea is that you like nest them and chain them together, which would be cool. So we need type, not typo, response. We're going to use our HTTP response that we made. Anyhow. But yeah, that's kind of what I want to do with the stream, is like use it to boost repos, like exactly what you're talking about with the MLUA. You know, just get more sources out there for people to know about it. I think good work deserves to be promoted, you know. So allow Clippy type complexity. I don't know if I even have Clippy set up. I don't think I've started my my love-hate relationship with Clippy yet. Okay, so the future is a pinned box dynamically dispatching a future of type output, which is a result for its own response and its own error, and send. I hope we don't have to type that every time. But see, that's the cool thing about Rust, is that like normally a long line like that, I would just have to try to memorize, but I think I could actually remember this because it makes sense. You have to pin the box, and you have to dynamically dispatch the future, and then the future needs a result. And then you just always know what result is because you use it so much. Nice. Actually, I think that's the last type. Yeah, so now we need to implement already. mutable self. No. Okay. Mutable standard ask context. Okay, and that's all the parameters. See if they fixed that for me. Nope. And that's annoying. Okay. Wait, no, I'm missing something. I'm missing the return, obviously. It needs to return a poll. Right? Yeah. Results. This is always ready to accept a connection, right? So after all that, that's all we're doing. Just implementing pull ready to always accept. So it takes a reference to context that we don't use. So we make it anonymous with the underscore. Okay. So call is going to be more complicated than that because it's all of our logic. This is going to be reference to mutable self, mutable request to our HTTP request. Why does it matter that you would, Lord, why would it matter that your config is in Lua versus the regular version? Like, what's the difference? Does it work better? Like, is it faster or something? I'm used to not using any of them at all, so it seems pretty fast when I do anything. Let me just start closing these before I lose track. Because VimScript is just horrifying syntax-wise, and Lua is also a few orders of magnitudes faster. Oh, really? Well, I love faster, and I like Rust. Okay. Yeah, I like the idea of just... So yeah, more flexible. It's more similar to a normal programming language, and it's faster. Okay, those are all good reasons. That's one of the reasons I like Rust so much is that, like, theoretically, you can just build so much of it with Rust, and then once you know Rust, you can just change any part of everything. That seems super powerful to me. But I'm probably just naive. I haven't. Yeah, we'll see. See if we can do some stuff with Lua. It's exciting. So we're going to print handling. So we're doing a box pin for our async move handling a request. This. That's not how that works. Okay. request dot. Okay, and then we access the path inquiry that we had. Just to print it. Pinbox async, box pin async move. That's okay. So we're moving the request into the pin box, and we're cloning the counter because are we also moving that somewhere? Yes. Okay, we're moving that now. Counter dot fetch add 1. It's going to read sync Tonic. Seek text. Okay. Anyhow, ensure or doesn't equal or counter mod 4 doesn't equal 2. So that's gonna what? 0. So 0, 1, and then 2, it would be negative. So it would be true, true, false, true. True, true, false, true, true, true. And then it just keeps repeating. I think. So, yeah, so failing 25% of the time. That is not, you must have done that before because that is not, it would have taken me a minute to figure that out. Anyhow, ensure though, that's not something I've seen before. That's cool. Request headers. So we're inserting the headers. X counter to owned. Which is a string slice, I think. String. Okay. So we insert our header as X counter, the request, and now we build our response. That's a response from our response struct that we built. Status 200. Request headers. Body. Request body. Definitely missing something. I'm missing the close on the move. Okay. Also missing this. Because it's a variable. Okay. And then we need. So we're going to return OK of anonymous. So I think we're just helping the compiler here, right? To fix the error type. Yeah. So this is just like OK response with an adjusted error type, which makes sense. So we're printing the path in the query. We're incrementing the counter. We're failing 25% of the time. I'll have to look at the anyhow crate. That's interesting. And then we're pushing the headers with an insert and the counter. Oh, so this is like, yeah, so we're making a hash map here of X counter with the number. And then our response is going to be 200 with that header and the body. What's the body though? Body for requests. Response. Q8. Like I'm missing something. Oh, I just messed up. Oh no. What are all these errors? I gotta fix this too. I think it's my CSC. But so this probably has a bunch of errors in it, but it should work once those errors are fixed. So let's go back to the article now. Sorry for not paying attention. I was busy contributing 2 lines of code to my favorite error handling lib. Yeah, no worries, man. You never have to apologize for contributing to open source. That's what the world's built on. Tiny contributions from lots and lots of people. What's your favorite error handling? I feel like you've shown me this before. I remember you telling me to use it all the time. I just forgot what it's called because I haven't done Rust in so long. Oh, might. That I've not heard of. Yeah, no. Maybe it was Del Papa who was telling me to use the other thing. Oh. Here. This is what I need. You run might. You run her code like the software. I feel like there's a joke here I'm not getting. The diagnostic library for Rust includes a series of traits protocols that allow you to look into its error reporting facilities. You can write your own error reports. It lets you define error types that can print out like this. Ah. Received unexpected JSON from the source. Here. It might be in term. It should be reported. Oh, nice. Keep us updated. I'll have to check this out too. Okay, where were we in this? Here, I should start here. That was all relatively abstract. Part of the problem with understanding Tower, at least for me, let's make it more concrete by implementing a fake web server and fake web application. This is the TOML. Uploaded the full gist. Let's walk through this example. So we define some helper types to represent HTTP response and request. Yeah, so this is what we already set up. We want to define a function run, which accepts a web application as an argument, loops infinitely, generates fake request values, prints out response values it gives from the application. The first question is, how do you represent that web application? It's going to be an implementation of service with the request and response types being those we defined above. We don't need to know much about the errors since we'll simply print them. Yeah, so error is just debug, and then service of request response that we defined of async phone. So there's one final bound we need to take into account. We want our fake web server to be able to handle requests concurrently. To do that, we'll use Tokyo spawn to create new tasks for handling requests. Okay. Therefore, we need to be able to send the request handling to a separate task, which will require bounds of both send and static. There are at least two different ways of handling this. Clone the app value in the main task. Cloning the app value in the main task and sending it to the spawned task. Creating the future in the main task and sending it to the spawned task. There are different runtime impacts of making this decision, such as whether the main request accept loop will be blocked or not by the application reporting that it's not available for requests. Decided to go with the latter approach, so we've got one more bound on run. Yeah, so the future needs to be send and static. The body of run is wrapped inside a loop to allow simulating an infinitely running server. First we sleep for a bit, then we generate our new fake requests. Yeah, sleep requests. Next, we use the ready method from the service extension trait to check whether the service is ready to accept any request. Is this from the service extent? Service not available accepts requests. Once we know we can make another request, we get our future, spawn the task, and then wait for the future to complete. Okay. Yeah. And then await the future. Okay. And just like that, we have a fake web server. Now it's time to implement our fake web application. It's called demo app. We give it an atomic counter to make things slightly interesting. Derive default counter arc atomic size. Next comes the implementation of service. The first few bits are relatively easy. Tower service create HTTP request for demo app. Response error, is it anyhow error? And then allow type complexity. So I guess Clippy normally says like, don't do this. Do something else. This is too much. And they're right. But I should really set up my Clippy so that I have a robot to pair program with. Okay, so we need to still make pull ready and call. That makes sense. Request and response get set to the types we defined. We'll use the wonderful anyhow creates error type, and we'll use a trait object for the future. We're going to implement a pull ready, which is always ready for a request. Function pull ready. Self mutable standard context, standard task context. Returns pull results. Okay. Finally, we get to our call method. We're going to implement some logic to increment the counter, fail 25% of the time, and otherwise echo back the request from the user, which added X counter response header. It's basically what we saw before. Should make a stream installing Arch, and one porting your nvim config to Lua. Opportunity to swap anyhow for might. How do you pronounce that? Might? Mate? Is that what's the how do I write this? Where's the GitHub? Here? No. Struggling. There we go. Me yet? Okay. We'll pronounce it me yet then. What is a sponsor? I don't think I've seen that before. Only this many stars. Let's give it a star. Do you just always use this for any error you can? Man, this is nice. How would I do a stream for setting up Arch? Wouldn't I have to replace my Ubuntu? Or can I download it, install it, and then move everything over? I guess I'm not exactly sure how that works. Even it's been a while. Without a test run and a VM. Oh, just do it in a VM. Yeah, I mean, I'd be too scared to do that too. I'd have to like back everything up. But yeah, we could try that. I'd be down for that. I should write this down. Let's see. Switch to Arch. And then, what'd you say, the Lua thing? Porting your nvim config to Lua. How does the nvim config with Lua work for the plugins? Is there just a Lua equivalent of most plugins? I guess I already read that. Yeah. Yeah, good tips. You gotta back up everything you care about first. Yeah. It's gonna wipe your Ubuntu stuff. You're gonna do it since there's no installer. I'm gonna wipe all the Ubuntu stuff. Good, 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 good. It supports VimScript and Lua plugins. Okay. I see. So you can run both. Is it with Arch, is it hard to do stuff? Like, I guess, like install stuff and things like that once it's set up? I guess setting it up is kind of a, like if you can set it up, you can do all the other stuff, right? It's more of an ability type thing. You should use a different plugin manager that integrates better with Lua. Hacker.nvim, namely. Okay. Everything is at least 10 times easier. Oh man. A minimum magnitude increase? That's my kind of deal. Now I'm excited. All that in place, running our fake web app on our fake web server. It's nice and easy. No more adding apt repos. Self-destructing package manner, outdated stuff. I'm gonna have to look into this because this sounds like a magical world that you're selling me. One thing that's particularly unsatisfying about the code above is how much ceremony it takes to write a web application. I need to create a new data type, provide a service implementation for it, and futz around with all that pinbox future business to make things line up. The core logic of our demo app is buried inside the call method. It would be nice to provide a helper of some kind that lets us define things more easily. It really is. All right, I believe you. You've never steered me wrong so far. You told me to stop doing Python, and I didn't listen to you. And here we are. You can check out the full code as a gist. Let's talk through it here. We're going to implement a new helper app function, which takes a closure as its argument. That closure will take in a request value and then return a response. But we want to make sure it asynchronously returns the response. So we'll need our call to look something like, is this a different gist than the other one? So I don't remember this. You can have it now for the low price of nothing except your life and all your friends because you'll be obsessed with free software. Worth it. I mean, I'll just get new friends. I had the foresight to have a low number of friends to begin with. That's thinking. I think this is different. Let's see. Exactly. Okay, so this is different. Crap. So 30. Got nothing to lose. Exactly. The real genius. Minimal friction. Okay, so the fake server is the same, I think. This util is similar? It looks similar. I can see both, actually. So I have two screens. The magic. Okay. So instead of building an app, he's building util. And then moving some of our call stuff into this util app function closure. Let's see. Ask any Arch chat room, and everyone will agree that Python is trash. Another good thing is that our average Arch user hates Python, so there's no chance we'll go back to that ever. I mean, the amazing habit of not being able to see Windows without getting mad at the Windows user. Okay. Well, what if I need to use Python? Asking the hard questions. I feel like I just ticked a domino. You know what I mean? By using Python and need in the same sentence. You'll find a way not to use it. Where there's a will, there's no Python. Okay, let's see. Let's fix our thing to match this. I mean, I feel like Python just has so much momentum now. Like, it's got all the hype of machine learning and cloud stuff and NumPy. God, that's gonna be bad. Yeah. Begrudgingly using Python. Okay, so what are we doing here? I guess it's going to be util now. And then how much of this is the same? How much of it is different? Are we not? We're not doing a lot of this anymore. Let's see. Still need future. Still need poll. But I don't think we need the rest. And then demo app. I'm going to confuse myself. I can guarantee that. Okay, well, let's just go from here. So I don't see this anywhere, which is interesting. I don't see this anywhere either. What I do see of structs. Function. Make sure it's in. Hey, buddy, here. Come on. Come on. Come on. Upper. Bork. Yeah. Oh, don't lick the mic. Oh. Here, sit like this. Sit like this. I don't know if it's just us, but the dog has gotten severe separation anxiety since the lockdown, and we've both been working from home. Where was I? App function uses f and read. Returns app function. Wait. What have I done? I've done this entirely wrong, I think. No. I'm fine. Co-op coding. Yeah, with the dog. Just pair up with someone of approximate skill level and start hacking away. Function. Okay, so now I'm making the app function like he was saying. That's why I got confused. Takes an F. App okay. Where HTTP request do this whole song and dance. Create HTTP response. And then just takes this. I think Miss Borks thinks this is interesting. Yeah. She's always interested as long as she's getting attention. But she only wants attention from me when her mom's not home. I'm like, just doesn't even try to hide it that I'm second tier. Okay, so then we're going to implement this stuff for our service. Okay, so this should be very similar to our other service. So let's try that. Let's see if we can stitch this together. We need to add our types that we're going to use. And then request for app function. Okay, so we switched the demo app with the app function. And then the struct holds a function. I think that's what's happening. App function of f. Right? Okay, and then we have to put this here. We have to put this here like we did for the function. Right? Is it it's the same? Okay. So let's just do this. Okay, that should work. Oh man, she's so bored. You ever think of things from the pet's perspective? It's like, why are you just sitting there clacking away? Why do you guys stare at screens so much? Don't you know there's squirrels outside? Let's see, already. I think the rest of this is the same. This is not the same because we define this type, which makes sense, right? Can I do this? Yes. Should be this. I think. And this is gone because it's no longer, or it's done properly, I guess. And then our function. That makes sense. Okay. Just double check the rest of this. Okay, so our call is very different. Our call, I think we move, still has the same parameters and output, but I think all of this gets moved down here. Instead of that response type def, you could also just use response. This. You're saying because I put the mod up here. This. Wouldn't I have to do HTTP response? Where was I? Use create. Wasn't this enforcing that response has to be our response and not the default service response type? This is also just wrong. Or no? Okay. Yeah. Okay, we synced back up. Nice. How do I move? I always forget how to do this. Do it like this. Nice. Do it again. Nice. Okay. I love it when Vim starts to be intuitive. Hey, buddy. She's gonna be back soon. Don't worry. I'm not sure exactly how this all fits together though. So let's keep going. I think a lot of this call simplifies though, right? Yeah. Because we're just gonna call the function with the input. This is very, I mean, not that I really know, but this seems like a very Haskell way of doing this. So let's change down. Oh, the cat's coming to join us too. We got all the animals. There. So we're just going to call the function that's in our app function struct. And then the rest of the stuff will be down here. Vim is really intuitive for me, but the cost is always typing HJKL $DDO. Yeah. I always, whenever I'm working with someone that just doesn't even know that Vim exists, and I start doing that, I lose all credibility immediately. They're like, did you just have a stroke on your keyboard? What's going on? Hey, there's a cat down here off screen that is normally not super friendly to me anyways, or at least doesn't want attention, but is now demanding attention. It's literally never done this before. Okay. Bye. Okay, where were we? Yeah, so this is the thing. Let's see. Okay, yeah, so we're moving the counter down here. We're just putting our logic into main. And then putting functions into main, which I sort of like better actually. Tonic, view size 0. Big server run. It's not going to be demo app anymore. It's going to be just util app function. Wait, so can you just not use Python at all in Arch? I already get used to that. Passing it immutable requests into the closure. Or can you use it and you just get exiled from the community. A fitting punishment. Oh wait, we should probably move all of this. Ooh, I wonder if I can do this. Can I do this? Oh, nice. That was great. I did not expect that to work. Well, of course you can. But realistically, that's not going to happen. But hey, you can definitely avoid it much more efficiently or effectively. You'll definitely get punished if you write it. Most Arch users aren't as extreme as me with their opinion on Python. Oh, that is unfortunate. You should explain it to them. Did I do this right? I think I did this. I think this is right. All the demo app stuff is gone. You have and they tend to agree. Oh, is it one of those things where you like preach it to them and then everyone nods their head and then goes and does it anyway? Yeah. Yeah, that makes sense. People love to do that. So we shouldn't be waiting here? No, we should. We should, but we're missing something, I think. So we're doing this on the pin, but then this, yeah, this is very wrong, right? This should be here. This is for the fake server. This is for the closure. Oh, so we need, well, we need one on the inside, right? So this is for the pin. And this is for that. And then we need one for the run, right? Okay. What else are we missing? I think that's it. Let's see. What is this? What am I missing here? Do I just have an extra thing now? Oh, I also need to set, I have my Vim set up so that it pushes starting from this line, but it's kind of annoying. I need to fiddle with that and make it smaller. Because it moves it when you scroll. I think this is extra. That's what's happening. That's that. That's that. That's that. Yeah. Okay. Is that it? I think everything else is the same. Yeah, because this is just server stuff. Okay. Let's do that. Go back. Back to this. You can't hear her, but she's just in my lap grunting disapprovingly because I'm not as good as her mom. Capitalize the self in the return type of that function where you have an error. Self of this. Saying this. return type. Oh. Where? This? No, this. Does that have to be capitalized? Crap. Keep doing that. Okay. Where were we? Oh no. Oh wait, no. Okay. It saved it. It was in the buffer. Nice. Okay. I didn't know that had to be capitalized. Why does that have to be capitalized? Anything? I guess I've not really returned self before. Reading the error message helps. Another benefit of Rust. Because it's referring to the type, self is essentially an alias for the struct the method is in, right? And not self as in the instance of self saved in the variable called self. Right. Oh, because it's a type. I see. It's an alias of a type, so you still have to match the type convention. Whereas like this is a variable. This is a type. I see. That's a good distinction. What? Did I not increment something? Oh, is this just because it's in the closure? I think. People disagree which one is the right one. Yeah, no, I think I agree with you. It makes sense to do it that way. So we're going to implement a new helper function, new helper app function, which takes a closure as its argument. That closure will take in a request value and then return a response. But we want to make sure it asynchronously returns the response, so we'll need our calls to look something like app request async. The app function needs to return a type which provides our service implementation, which is the self, right? Let's call app function, put these two things together, and we get, so you make the struct that takes the function, and then you make the function that is at least our struct, or no, that is at least a function, and returns a struct holding the function. Okay. It's like initializing it. So far, so good. We can see with the bounds on app fun, we'll accept a request, return some return. Yes. Return must be a feature that produces a result response error. Implementing service for this. It's not too bad. Now, quick. Yes. Yeah, this is basically what we did. This is a trait of service for, yeah, so we're, instead of building service, we're implementing service on, so that's how we did the first time, right? The first time, where is it? We implemented service on the demo app. And the demo app had the counter. Now we have the counter in main. And we have our function in our struct. We have the same bounds as an app function. The associated types response and error are straightforward, and pull ready is the same as it was before. First interesting bit is type future equals read. We previously went the route of a type object, or of a trait object, which was more verbose and less performant. This time we already have a type, read, that represents the future the caller of our function will be providing. It's really nice that we get to simply use it here. The call method leverages the function provided by the caller to produce a new read future value per incoming request and hand it back to the web server for processing. And finally, our main function can now embed our application logic inside it as a closure. This looks like this. Now embed our application logic inside of this closure. Yeah, so we can just say run, and then move the request, and then put our logic here, as it's probably meant to be. Side note, so here's the extra clone. In bitter experience, both my own and others I've spoken with, that let counter equal counter.clone. Above is likely the trickiest piece of the code above. It's a little bit of a clumsy sentence, but above is likely the trickiest piece of the code above. Okay. It's all too easy to write code that looks something like counter arc new, arc usize new, fake server run, util app function move request async move, and then you just add the counter, and then you fetch, and then apparently standard sync atomic ordering sequential syst is how you increment. It looks reasonable, but the counter into the closure, and we move the counter into the closure and then use it. The compiler isn't too happy with us. It says move occurs because counter has type arc atomic usize, which does not implement the copy trait. So we can't move it. We can't move the counter. Move occurs here. We can't move it out, I guess. Let's see if he explains it. It's a slightly confusing error message in my opinion. It's confusing because of the formatting I've used. Now I've used the formatting because 1, REST format encourages it, and 2, hyperdocs encourage it. Let me reformat a bit and explain the issue. In the argument app function, we have 2 different control structures. A move closure, which takes ownership of counter and produces a future. Right. An async move block here takes ownership of counter. The issue is that there's only one counter value. It gets moved first into the closure. Oh, I made it worse somehow. That means we can't use counter again outside the closure. So it gets moved here, and then we can't it's moved into the closure, which is this, and then it can't be used here. I can't move out. That means we can't use counter again outside the closure, which we don't try to do. All good. Yeah, okay. The second thing is that when the closure is called, the counter value will be moved from the closure into an async move block. That's also fine, but it's only fine once. If you try to call the closure a second time, it would fail. But because the counter has already been moved. Okay, so it's already in the async, is why. The closure is fn once, not fn or fn mute. That's the problem here. As we saw above, we need at least a fn mute. I like saying it fn instead of function mute or fun mute or whatever. Because I don't know, it's funnier. As our argument to the fake web server. This makes intuitive sense. We will call our application request handling function multiple times, not just once. Yeah, we're gonna call it a lot of times. The fix for this is to clone the counter inside the closure body, but before moving it to the async move block. That's easy enough. Yeah, so we just clone it before putting it into the async, so that we can do this any number of times. It's a really subtle point. Hopefully this demonstration will help make it clear. It does help make it clear. Thank you, sir. There's a simplification in our web server above. A real HTTP workflow starts off with a new connection and then handles a stream of requests off of that connection. In other words, instead of having just one service, we really need two services. A service like we have above, which accepts requests and returns responses. A service that accepts connection information and returns one of the above services. So here we're just doing a simulation of it, skipping the connection portion, but you have to actually connect, doing real things. Again, leaning on some terse Haskell syntax, we'd want inner service is a request that returns an IO response. Outer service is connection info that returns the inner service. Yeah. Or to borrow some beautiful Java terminology, we want to create a service factory, which will take some connection information and return a request handling service. Or to use Tower hyper terminology, we have a service and a make service, which if you've ever been confused by the hyper tutorials like I was, they finally explain why Hello World requires both a service function and a make service function call. It's too detailed to dive all the changes necessary to replicate this concept, but he did this. Okay, we finally played around with fake stuff long enough. We can dive into real hypercode. The next post in this series is available. Yes, so we'll do this. Let's see if this actually runs though. I don't know. Let's see. Is it this? Get her. Bumps him. No more dog in the lap. Self-value is a keyword only. Oh, let's start from the top. Not found in the scope. Oh, did I not import arc? Also not found in the scope. Is a keyword only available to methods with a self parameter. And that's just because it doesn't exist yet. So what did I miss? I didn't bring it in. Somewhere? Where is it? Here. Let's see. Where was it brought in before? Okay, yeah, it was at the very top. That's the problem. Yeah, I definitely missed that. Okay. Need to use Sneak. Tonic. Use that. I don't think it will fix this though. Let's see. Shut the door. Self value is a keyword only available in methods with a self parameter. Line 100. Self counter clone. Yeah, that does make sense. Because our counter does not have a self. Duh. I don't know why that was there. Okay. What is this saying now? Variable does not need to be mutable. You're right. Because, man, I love the compiler. It's great. It doesn't need to be mutable because we're passing it to a closure now, I think. And Rust is great. You know how long that would have taken the problems that it saves you. It's wonderful. Let's try again. Nice. So let's see. Build. Nice. Beautiful. But this is skipping the factory. What is it? What does Hyper call it? The make function. What is it called? App factory function. Yeah. Yeah. Make service function. There's a service function and a make service function in case you want to do multiple. Let's see. I don't think we're going to do the coding part of this next one, but we'll go through it. Yeah, I don't think there's a gist for this. I tried to check beforehand and I couldn't find it. So if anyone finds it, put it in the, I don't know, put it anywhere, put it in the comments, I guess. So let's see. Tower provides a service trait, which is basically an asynchronous function from requests to responses. Service is parameterized on the request type and has an associated type for response. It also has an associated error type and an associated future type. Service allows async behavior in both checking whether the service is ready to accept a request and for handling the requests. A web application ends up having two sets of async request response behavior. Inner, a service that accepts HTTP requests and returns HTTP responses. Outer, a service that accepts incoming network connections and returns an inner service. Okay, with that in mind, let's look at Hyper. Services in Hyper. Now that we've got Tower under our belts a bit, it's time to dive into the specific world of Hyper. Much of what we saw above will apply directly to Hyper, but Hyper has a few additional curveballs to deal with. Both the request and response types are parameterized over the representation of the request-response bodies. There are a bunch of additional traits and type parameterized in the public API, some not appearing in the docs at all, and many that are unclear. In place of the run function we had in our previous server example, Hyper follows a builder pattern for initializing HTTP servers. After providing configuration values, you create an active server value for your builder with the serve method. just to get it out of the way now, this is the type signature of serve from the public docs. Oh my goodness. This. So this is hyper serve. SB self new service. It returns server ISE error into, what does this do? Box dynamic standard error send sync. This is for all of them. All the errors are the same. Okay. Make service ref iConnection. Accept from iConnection. So the connection is async read, async write, unpin, send and static. And then that goes to this. I think he's going to explain this. So that's a lot of requirements. Yes. And not all of them are clear from the docs. Hopefully we can bring some clarity to this. For now, let's start off with something simpler. The Hello World example from the Hyper homepage. This is Hyper. I want to check this out. Go. So let's see. What are we doing here? Standard convert infallible net socket address. Hyper body request response server. Service make service function service function. Okay. Async function handle request body returns result response body infallible. Okay, response new hello world that into Tokyo main async function main socket address. This makes service function takes a connection to a closure. Async says okay infallible service function handle. And then our handle is just going to take a request body, and then no matter what it is, we're going to return the response hello world. Okay, but server equals server bind address serve. Okay, so now we're sort of chaining stuff together. So our server is getting bound. So we have a hyper server. We're binding to this address. So we're doing like real stuff now, sort of. Serve make service. Let error e server await eprint. Okay. This follows the same pattern we established above. Handle is an async function from a request to a response, which may fail with an infallible value. Both request and response are parameterized with body, the default HTTP body representation. Okay, so that's just like to be generic. Handle gets wrapped in a service function to provide a service request body. This is like app function above. So that's why he did it that way. So that our brains would be ready for the API of Hyper. I appreciate that. Yeah, because make service function takes a closure to this that implements the service. That makes sense. Okay. We use make service function like app factory function above to produce the service referenced address stream. We'll get to that address stream shortly. Okay, so he's going to explain that. We don't care about that value, so we ignore it. Where? This? Just talking about this. This is connection. Wait, where does connection come from? Is it just generic? Doesn't matter. It's this. Right? Service interest stream. Where is that? Let's see it. Am I blind? It must be in a different bit of code. The return value from the function inside makeService function must be future, so we wrap with async. Yeah, so that's why this is here. It's because this has to return a future. Which our service function should do. Okay. The output of that future must be a result, so we wrap with an OK. We need to help the compiler out of it and provide type annotation of infallible. Otherwise, it won't know the type of OK service function handle expression. Using this level of abstraction for writing a normal web app is painful for at least 3 different reasons. Managing all the service pieces manually is a pain. There's very little in the way of high-level helpers like parse the request body as a JSON value. Any kind of mistake in your types may lead to very large non-local error messages that are difficult to diagnose. So we'll be more than happy to move on from Hyper to Axum a bit later. But for now, let's continue exploring things at the Hyper layer. Yeah, so there's like, Axum is using like multiple layers of abstraction, I guess. It's fine with me. Bypassing service function and makeService function. What I found most helpful when trying to grok Hyper was implementing a simple app without service function and makeService function. So let's go through that ourselves here. We're going to create a simple counter app. Nothing if not predictable. I love it. We'll need 2 different data types, one for the app factory and one for the app itself. Let's start with the app itself. So we're doing another demo app like we just did earlier. And then this all looks pretty much the same except we're using a hyper error here instead of the anyhow error. And then that's the same. Right, yeah. Which adds 1 standard sync atomic ordering. Okay. Oh, that seems pretty much the same. This implementation uses the standard future ready struct to create a future which is immediately ready. In other words, our application doesn't perform any async actions. I've set the error associated type to hyper HTTP error. Oh, that's right. Right? It's just using future ready. So it's not async, it's just always that's gonna block, right? I think that's how it works. This error would be generated if, for example, you provided invalid strings to the header method call, such as non-async characters. As we've seen multiple times, already just advertises that it's always ready to handle another request. The implementation of demo app factory isn't terribly different. Yes. Okay. So what is different? This. It's returning a future ready of OK. So this is just always ready. This is infallible. The error is infallible. The response is a demo app because we're a factory now. This is accepting the request. And then we just do the clone here for the counter of the demo app. We have a different parameter to service. This time, reference to address stream. This is what we're talking about. Connection is an address stream. I did initially find the naming here confusing. In Tower, a service takes some request. And with our demo app, the request it takes is a hyper request body. But in the case of demo app factory, the request it's taking is an address stream. Keep in mind that a service is really just a generalization of fallible async functions from input to output. The input may be a request body, or maybe an address stream or something else entirely. Calling it a day, it's 2:30. Jeez. Yeah, man, go to bed. What are you doing? Anyways, yeah. I'll see you next time, hopefully. Thanks for hanging out. Back next Friday for the rest of this. We're almost done anyway, I think. Won't be long. We'll try to stream on the weekend so you're not staying up to such an hour. So similarly, the response here is an HTTP response, but a demo app. Yeah, so it responds the app instead of the response. Which is not the best way to say that, but I again find it easier to use the terms input and output to avoid the name overloading of request and response. Yeah. Everything's just inputs and outputs. Just don't make it too complicated. So finally, our main function looks much the same as the original from the hello world example. Yeah. So Tokyo main, async function main, the address, socket address from a random port. Let factory equal demo app factory that returns that has a counter of arg new atomic usize new 0. Let server equal server bind to the address.serve factory. So if let error e equals server.await eprint line server error e. If you're looking to extend your understanding here, I'd recommend extending this example to perform some async actions within the app. How would you modify future? If you use a trait object, how exactly do you pin? But now it's time to take a dive into a topic I've avoided for a while, understanding the traits. Let's refresh our memory from above on the signature of serve. Yes. Up until preparing this blog, I have never tried to take a deep dive into understanding all of these bounds. So this will be an adventure for all of us, and perhaps it should end up with some documentation PRs by me. Let's start off with the type variables. Altogether, we have 4, 2 on the imp block itself, 2 on this method. I represents the incoming stream of connections. Okay, so I for incoming. E represents the executor, so not error, executor. Connection stream executor, new service executor. Okay. S is the service we're going to run. Using our terminology from above, this would be the app factory. Using Tower Hyper terminology, this is the make service. B is the choice of response body the service returns. The app, not the app factory. Okay, so this is the input. This is the service. Wait. No, this is the service factory. Make service ref. This is the service. This is the executor. So you need an input, a service, which requires a service creator, and then you need an executor. Okay. Okay. I accept. I needs to implement the accept trait, which represents the ability to accept a new connection from a source. The only implementation out of the box is for address incoming, which can be created from a socket address. And in fact, that's exactly what server bind does. Accept has two associated types. Error must be something that can be converted into an error object, or into box dynamic standard error send sync. This is the requirement of almost question mark. Every associated error type we look at. So from now on, I'll just skip over them. We need to be able to convert whatever error happened into a uniform representation. The connection associated type represents an individual connection. In the case of address incoming, the associated type is address stream. This type must implement async read, async write for communication, send and static lifetime so that it can be sent to different threads, and unpin. The requirement for unpin bubbles up from deeper in the stack, and I honestly don't know what drives it. Well, there's always a bigger fish, right? So S make service ref. Make service ref is one of those traits that doesn't appear in the public documentation. This seems to be intentional. Reading the source, just a sort of trait alias of make service, not to be implemented by anyone, only used as bounds. Were you confused as to why we were receiving a reference with at address stream? This is the trait that powers that transformation. Overall, the trait bound S make service ref I connection body response body equals B means S must be a service. It will accept input of type reference to a connection. It will in turn produce a new service as output. That new service will accept request body as input and produce response body as output. Okay. Sort of makes sense. While we're talking about it, that REST body has the restriction that it must implement HTTP body. As you might guess, the body struct mentioned above implements HTTP body. There are a number of implementations too. When we get to Tonic and gRPC, see that there are, in fact, other response bodies we have to deal with. New service X in connection stream executor. The default value for the E parameter in X, which does not appear in the generated docs, but of course you can find it in the source. The concept of X is to specify how tasks respond to off. By default, it leverages Tokyo spawn. I'm not entirely certain of how all these play out, but I believe the two traits in the heading allow for different handling of spawning for the connection service app factory versus the request service app. Okay. Good to know I'm not the only one that doesn't understand everything. Axum is the new web framework that kicked off this whole blog post. Instead of dealing directly with Hyper like we did above, let's re-implement our counter web service using Axum. We'll be using Axum 0.2. The crate docs provide a great overview of Axum, and I'm not going to try to replicate that information here. Instead, here's my rewritten code. We'll analyze a few pieces below. So Axum extract extension, Axum handler get, Axum add extension layer router, Hyper header map service status code, standard net socket address, standard sync, Tonic view size, and arc. Okay, so we're deriving clone and default, app state, And then we're putting the counter. It's the arc. And then in our main, well, are we just doing everything in main? Oh, we have a, oh, what? So we make the address to our import. Ah, okay. So we make our app as router new, and then we give it a route. Oh, this looks nice. This looks nice. Router / get home. Layer, add extension layer, new app state default. That server equals server bind address dot serve app into make service. Ah, so you can do dot into make service. That's nice. And then if let error server error. And then wait, what is home? Get home, I see. That's why it looks so nice. State extension app state status code header map string, where the string is the body. Yeah, it's got to be counter equals state dot counter. So we called this app state. Extension app state. State.counter. Oh, we named here. Okay. Okay. Then increment with standard async atomic ordering sequential cast. Let mutable headers equal header map new. Then insert context type text plain UTF or charset UTF-8 parse unwrap. Let body equal format. Okay, yeah, so counter status code okay, headers, body. First thing I'd like to get out of the way is the whole add extension layer extension bit. This is how we're managing shared state with our application. It's not directly relevant to our overall analysis of Tower and Hyper, so I'll suffice with a link to the docs demonstrating how this works. Interestingly, you may notice that this implementation relies on middlewares, which does in fact leverage Tower, so it's not completely separate. Huh. Where? This? No. Headers insert? No. Get, route get, I don't know. Where's socket address come from? Standard? Standard net, okay. Okay. Anyway, back to our point at hand. Within our main function, we're now using this router concept to build up our application. Let app equal router new, route get home, layer add extension layer, app state default. This says essentially, please call the home function when you receive a request for / and add a middleware. So this is the middleware for layer that does the whole extension thing. The home function uses an extractor to get the app state and returns a value of type status code header map string to represent the response. In Axum, any implementation of the appropriately named into response trait can be returned from the header functions. Anyway, our app value is now a router. But a router cannot be directly run by Hyper. Instead, we need to convert it to a make service, an app factory. Fortunately, that's easy. We call app.intoMakeService. Yeah, that's cool. Let's look at that method's signature. Implement s, router s, pub function into make service self, into make service s, where s clone. And going down the rabbit hole a bit further, pub struct into make service s, implement s clone t service t for into make service. Type responsive is s, type error equals infallible. The type router s is a value that can produce a service of type s.intoMakeService. We'll take some kind of connection info t and produce that service s asynchronously. And since error is infallible, we know it can't fail. But as much as we say asynchronously, looking at the implementation of service for intoMakeService, we see a familiar pattern. Already, feature make service routine, make root service future. Feature ready okay self.service.clone. Also notice how that t value for connection info doesn't actually have any bounds or other information. True. intoMakeService just throws away the connection information. If you need it for some reason, see intoMakeService with connection info. In other words, router s is a type that lets us add routes in middleware layers. You can convert a router s into make service s. But intoMakeService s is really just a fancy wrapper around an s to appease the hyper requirements around app factories. So the real workhorse here is just s. So where does that s type come from? It's built up by all the route and layer calls you make. For example, check out the get function signature. Pub function get hbt handler h on method hbt empty router, where h is a handler bt. Public struct on method hbtf for the future. Implement hbtf service request b for on method hbtf. So it takes a handler of hbt or bt, and then future, which is a service request response, which has a response box body. Request B, response box body, error infallible, plus clone. And then B is send in static. Response box body, yeah. Error infallible. Okay. Man. Get returns an on method value. And on method is a service that requires a request B and returns a response body. Some funny business at play regarding the representation of bodies, which we'll eventually dive into a bit more. But with our newfound understanding of tower and hyper, types at play here are no longer inscrutable. In fact, they may even be scrutable. And one final note on the example above, Axum works directly with a lot of hyper machinery, and that includes the server type. While the Axum crate re-exports many things from hyper, you can use those types directly from Hyper instead if so desired. In other words, Axum is pretty close to the underlying libraries, simply providing some convenience on top. It's one of the reasons I'm pretty excited to get a bit deeper into my experience with Axum. Nice. So, to sum up this point, Tower provides an abstraction for asynchronous functions from input to output, which may fail. This is called a service. HTTP servers have two levels of services. The lower level is a service from HTTP requests to HTTP responses. Upper level is a service from connection info to the lower level service. Hyper has a lot of additional traits floating around, some visible, some invisible, which allow for more generality and also make things a bit more complicated to understand. Axum sits on top of Hyper and provides an easier to use interface for many common cases. It does this by providing the same kind of services that Hyper is expecting to see. Axum sits on top of Hyper and provides an easier to use interface for many common cases. It does this by providing the same kind of services that Hyper expects to see, and it seems to be doing a bunch of fancy footwork around HTTP body requests or representations. Next step on our journey as well, let's look at another library for building Hyper services. We'll follow up on this in our next post. Man, I feel like I learned a lot there. I hope you did. Maybe I'll understand it better after I go to sleep. I hope so, because that was a lot. But we will be back next week to go over part 3 and 4. And then I'll probably put a video out that's much, much shorter. Yeah, thanks for stopping in. Like, comment, subscribe, all that good stuff. And hope you have a good one. Let me